Hello, everyone. Yeah, I just see the chance to be here in the Sian Fair to introduce Tecnalia, but Damien will talk especially on these projects. So Tecnalia, we are. Yeah, you want me to stay on the camera? All right. So Tecnalia, we are a technological center based in Spain, in the northern area of Spain, Bilbao, San Sebastian. We are 1,500 people. We are the largest applied research and technological center in Spain. It's true. And just a few things I wanted to mention. We are the Sian Fair, which is really industry oriented. Just to precise that manufacturing industry is at the DNA of Tecnalia because the ecosystem there is really oriented to the manufacturing industry. So in the Basque country, we have automotive industry, aeronautic industry, railway industry. So that's something I wanted to mention. And also, we collaborate obviously with France. So we have historically a team in Montpellier. We collaborate in that context with the LIRM. We also have customers in France. And yeah, and in robotics, just to finish, in robotics, we collaborate. We are able to collaborate with robotic manufacturer, with users slash integrators. And that's it. I wanted to say, Damien. I let you complete if you want. Feel free.
Okay, thanks a lot, Simon. You can hear me, yeah? Okay.
Yes.
So no, that's Tecnalia. It's Applied Research Center. We have a few of them in Europe. It's a model that I don't know if you guys have in the States or in Canada, but it's private, non-profit. And what we do is that we develop technology, we make it more mature, and then we transfer it to companies. So we don't make any products. What we do is R&D projects, innovations, and we need to be financially sustainable, but the business is done by the companies to whom we transfer the technology. Can be transferred by in the form of R&D projects or transfer of patents, IP, things like that, you know. So in terms of robotics and automation at Tecnalia, we are about 85 people, and we deal with all kind of applications. Tecnalia is segmented vertically by sectors. We have construction, we have health, we have manufacturing, we have digital systems, energy. I think I said it. I mean, all the industrial sectors are covered. And so in terms of robotics and automation, we are a lot focused on manufacturing, but not only. We also have people developing flying drones. So that's a taxi, an aero taxi, autonomous vehicles, inspection robots for nuclear environments, lots of mobile manipulators for the industry, collaborative robots, but also things for surgery and assistance of exoskeletons for impaired people, but also for workers. And everything that is a machine tool, a test bed now is also a very automated machine. So the segments we had before very close, they are getting all merged together. Simon was mentioning the LIRM. We developed with LIRM the cable robotics technology that we exploit and we sell to customers. So these are basically the smart cranes. And that's an example that I'm going to use today to explore one of the projects that we are doing in marine robotics. So that's in the scope of a European project called Maesltrom. Maesltrom basically is finishing this year. And we tackled the issue of marine litter, all the garbage that is in the ocean, in the rivers that end up in the fish that we eat, and also on the beaches. And it's a really huge issue. So this project tackled both the issue of knowing where this garbage is, how to remove it, and how to recycle the plastics and marine litter that we got. Okay, and so in that Tecnalia, we are focused on the technology to remove the marine litter from the seabed, so not on the surface, as there are other projects that can do that, but on the seabed, and also how to sort these things to collect, well, the plastics and all the things that can be recycled. Okay, so when we think about the seabed, we said, okay, what is done now. What can be done? Well, lots of that is divers, small rovers, small walking robots that are trying to catch cans with a harpoon or something like that. And there's also the big guys that make the dredging or the cleaning of the bombs in the Baltic Sea when they put the windmill farms, but they just like garbage everything. So it's really destroying the environment. So we wanted to find a kind of intermediate solution for that, and that's the contribution we brought. That's a floating platform on which we place 4 towers, and on these towers we have the winches and the cables that connect to the head of the robot. And by controlling the length of each of these 8 cables, we are capable to move the robot in the 6 degrees of freedom. And so for the first time, we put it underwater. So the floating barge is serving as a base, but then the head goes up to 20 meters depth. Okay. And that's actually a transfer from technology that comes from an industrial world, okay, from the scientific project that we do with the Liam, where here you see mobile manipulator, cable robot plus an arm that is capable to drill concrete. We developed an industrial crane with a company here in the Basque country that sells it. And that allows to have a very high capability crane. And you also have the option to have the hoist, so you can go up to 5, 10, 20 tons, but you have the control and the safety of the cable robot. And so for that, that's basically what we brought to this marine litter ecosystem issue. And so we added to the head some sensors. We have lots of cameras there, a DVL, smart camera, and also a depth sensors, thing like that. And also we have a gripper and a section tool. And we have here a small video. I'm going to remove the sound. We deployed it in Italy, in the Venice area, in 2 areas. One within the lagoons of Venice, in one of the hotspots that was historically a garbage dump. So now they collect everything in these big boats, but before just like throw it in the water, like everyone else. And so we deployed the robot. You can see the capability of motion. This blue tube is the suction device. So the idea was to suck the cans and small objects. At the end of the day, it was like more embedded on the seabed. So we just collected the mud and the small plastics was inside. So that's the area that we worked in. And yeah, so that's one of the deployments area. And you can see here, it was very fast, but basically that's a bathymetric map. So it's like a depth map of the seabed, and that's everything that is inside that obviously would need to be cleaned. You can think that we see tires. Here it looks like poles. The real thing is that from what you see from this 2D image and the reality, there's a huge difference. But that's part of the lectures that you learn when you go there. For example, this is not a crate, there's not a pole, but it's half a boat, but it's embedded on the sea, on the mud, and you only see a part of it. Oops, sorry about that. And so what we do is that we use this bathymetry map as a reference system, and the Liam developed a software API to actually place the platform that we control or we position using 2 RTK GPS and inertial using measurement units, so that the cable robot, with the model of the cable robot, we have the very accurate positioning of the gripper, and we're able to dive just on top of the object that we suspect that we need to take. As you've seen, the visibility is very bad. So we had to implement image enhancements software for to have a capability to see something. Visibility in this area is like 30 centimeters, so it's really difficult to see anything. So that was one of the areas. So we removed lots of big objects, lots of tires, lots of concrete parts, lots of machines parts. Very interesting work. And then the second target application was to go in the sea, in what is old mussel farm, like a fishery farms, you know, for mussels and clams. And here they just decided that they didn't want to use it anymore. So they just like cut the ropes and dumped it everything. So there's like hundreds and hundreds of meters of ropes and buoys on the seabed. Here we are about 17 or 18 meters depth, and the visibility, as you can see, is much better. The accuracy of the robot is very good. It was quite fast to actually go there and be able to pick the objects. We had to go there only during good weather. That's also part of the change between doing robotics in a lab and going at sea. We had to learn that conditions are really impacting the capability to work. And that's also something that we learned is that the emus that we used were getting lots of noise. So we couldn't implement the compensation of waves that we wanted to have. So that's why you see a bit of the motion of the gripper on the seabed. So with so much metal, the emus didn't provide information that were enough. Now that's how we collected the ropes. It's hundreds of meters, and it's also partly put in the sediment. So it's really, really heavy to lift. So we had to make lots of go and back motions to be able to actually collect all the information. So that's a project that was very important for us to work on the capability to do something with robotics for the environment. Okay, we can have the green robotics, making robots better. And we wanted also to do robot for green. What can we do using robots for the environment? So on top of the technology, we developed also lots of environmental diagnosis of before and cleaning technology. What did we impact in terms of ecosystem and so on? And also we did a very big life cycle analysis to actually see how much this technology also impacts the environment, because it's good to clean, but if cleaning you make more issues, that's a trade-off between apples and pears. But anyway, that's a technology that's working very well at the moment. It's a bit difficult in terms of logistics to move around. As you see, we need a boat there or a bigger boat to go at sea, but it's working very well. Just keeping through things. In the 2 campaigns that we did, we removed about 2.4 tons of marine litter. So that's a lot of work, lots of things taken out, and that comes from maybe 10 days plus 3 days. So let's say 2 weeks of work, 2 tons. Lots of different kind of objects, lots of also things that we'd have expected to have much more in the vicinity of a city like Venice, lots of food cans and single-use plastics, things like that. We didn't have that much. But anyway, now we're in the process of saying, okay, that's very good for the environment. The issue is that there's no regulation that imposes any city to actually clean the sea or the seabed or the canals or the ports. They have obligation to clean the streets, but no more. So it's difficult to have a business ecosystem that actually someone wants to put money to actually make the cleanup. We developed a prototype. We need to move it to industrial application, to a product. And so we're in this phase of looking at how we can do that. And so for this, we're looking at other operations that are done underwater, where this technology could be useful, so that going through a more commercial applications, we can get to a product and then use this product for the marine litter. So it's a kind of a win-win situation. We're looking at the moment things about the toxic waste, but also explosives and things like that. But we're very open to any creativity that you guys could have on where could we apply this technology. There's also in the area of Florida hundreds of thousands of tires that have been dumped in the past. We're discussing with people over there, but they're already removing them. So it's maybe not a big such a big issue for them. But anyway, we'd be happy to hear more ideas than the ones we have, or contact with people that are interested, and to try to bridge this gap. So that was one part of the project, collecting the marine litter. We had another partner doing that using bubble barriers in the rivers. So the floating plastics were catched before getting to the ocean. So it's even better. And then with all these marine litter, there's lots of vegetations, trees and wood, but also lots of plastics. And so we also made lots of beach cleanups during the project, and we developed a robot for the classification and sorting of this garbage and this waste. So in this thing, you see belts to help us not have to make so many manipulation, but that's basically all the well, not all, but most of the waste that we collected on beaches around Italy, Amsterdam, also the Basque country. And we put that on a system that here we have a tower with different cameras. For that, we have a hyperspectral near 2D and 3D. And that is used using an AI to be able to classify by material type. And then we have a robot that is capable to pick it, to separate it, okay? So we used a previous marine litter that was classified by lab tier, F tier, that gives you correctly the correct component, and also by manual sorting. We got a data set of hundreds, dozens, hundreds of images. And so what we do is classification based on pixel, on material type. We didn't have enough material to make deep learning completely on 2D image plus the near. So that's the next step that we want to do. And here you have an example of the robot sorting step by step all the waste that was on the belt initially. That's the first prototype of a robot. You can see, let's pause here. Here on the right, for example, you see the pixel-wise classification of these PET bottles. So red is PET. And here we then compute the picking point for the robot, and we go and pick it, okay? So obviously, lots of integration, lots of things to learn, lots of things to improve. As you can see, sometimes we have lots of packets coming. That's not very convenient because you can pick one stuff at the same place. So the sparsing difference to get more space between the objects is something that should be improved. And also we are now working on another project on construction waste. So these are big blocks of bricks, of wood, gypsum, stuff like that. So it's going to be rigid. So we need to go with a 2-finger gripper. And so we need to learn how we need to position the gripper to make the correct picks. We are going to work also on textile to get the fibers and colors classification. I mean, that's a prototype cell that we have, and we're going to deploy lots of classification AI to improve the different solutions for markets that are not yet available. So that's what we have at the moment. I think we have similar results to other companies that do sorting using robots. Our target is not to go directly to compete with them unless someone is interested to start up a new company, but it's more to go on a waste streams that are not treated at the moment. So that was, let's say, going back to the state of the art with the technology, and now it's fully controlled, and now we can go with different type of materials and so on. So that was it for us, but it was important for us to stimulate a bit the thinking about that's a lot of good things to do in robotics technology, but please also have a think about what to do for the environment and whether what we do is good or not, and how we can decide not to use robots for something that's not so good. Okay, bit of the same questions about what to do with the humanoids and all the robots that we can do. So you got my contact here. Any questions, we'll be really happy to discuss. And again, if you have good ideas for underwater stuff to do, please contact me.